All right. Hello, everybody. Good morning. So it's been almost 2 years since I published my first book on cognitive architecture. I called it Natural Language Cognitive Architecture, a prototype artificial general intelligence. It's available on Barnes& Noble in paperback. It's also available totally for free as an EPUB on Barnes& Noble and also on GitHub. So, anyways, the primary architecture, it's very, very simple overall. You've got this graphic here. So you've got the outer loop and the inner loop. And basically, with the recent updates to GPT, particularly the June 13th updates that allow it to be more steerable, we now have the ability to implement this very, very, very easily. And so what I'm going to show you today is the knowledge base service, or basically the shared database service that I created as part of a microservices architecture for autonomous cognitive entities or artificial general intelligences. So one of the first things to know is that basically we're moving away from coding, and we're using the model to do a lot more of the logic and reasoning. So here's the repository. It's private right now because I wanted it to be private while I was working on it, but by the time you see this video, it will be public, and it's literally just called KB Microservice. Knowledge-based microservice powered by GPT-4. Actually, I used 3.5 Turbo because it's good enough for chatbots, cognitive architectures, and autonomous agents. So here's the repository. I've got it documented, so it's easy to use. If there are any bugs, feel free to submit a pull request to fix a bug. But in general, I probably will not be accepting pull requests, especially if anyone tries to refactor this, because don't break it, please. All right, anyways, moving on. So let's unpack this. So the microservice itself, the primary one, is very, very simple. 159 lines of code. It's a Flask app, and the reason that I use Flask is because honestly, Flask is more straightforward than Fast API. I know that people like Fast API, but like it requires Unicorn and a few other things, and I'm like, just use Flask. So anyways, whatever. Personal preference. Neither here nor there. You're not going to run into speed constraints. Okay, so you can ignore the top stuff. These are just helper functions. We've got a few chatbot functions. So this calls the ChatGPT API. And you can see here that I have commented out GPT-4 because not everyone has access to it. Everyone should have access to 3.5 Turbo, which is faster and cheaper. And if it's good enough, great. And it is definitely good enough. So this is the primary function. Now here's the KB functions. So the endpoints available, let me just show you the documentation. The endpoints available are create, search, and update. So we can, this is basically CRUD, create, read, update, and delete without the delete, because my assumption is that you will never actually want to delete knowledge from your chatbot or your AGI. You might update an article if you get new information to correct it, but you never want to delete it. Kind of like it's permanent. You can easily add a delete function if you want, but I don't think it's necessary. So we've got these three endpoints. And it's pretty straightforward. If you want to create a KB article, you create a KB article. Pretty brain dead simple. So let's unpack how it does that. So if you call create, it ends up calling this function. Oh, and I have it call it in threads, so that it's non-blocking, because I realized a lot of these functions it can happen behind the scenes. You don't need to block your chatbot when you're updating a KB article or creating a KB article. The only time that it is blocking is when you search, because you might be waiting for that result. So the first thing that it does is it opens our system_create. So this is a system message that I passed to ChatGPT. Main purpose, you are a chatbot tasked with creating KB articles based on user input. Your output must only be a JSON object with the key title, description, keywords, and body. The user input may vary, including news articles, chat logs, and so on. The purpose of the KB article is to serve as a long-term memory system for another chatbot. So make sure to include all salient information in the body. Focus on topical and declarative information rather than narrative or episodic information. This information will be stored in a separate daily journal. JSON schema. So we define the JSON schema, title, description, keywords. The title will be used as a file name, so make sure it is descriptive, succinct, and contains no special characters. Description. The description should optimize for word economy, conveying as much detail with as few words as possible. Keywords. The keywords will be a simple string of comma-separated terms and concepts to help identify the article. Body. The body of the article should be in plain text with no markdown or other formatting. Try to keep the body under 1,000 words. Method. The user will submit some body of text, which may include chat logs, news articles, or any other format of information. Do not engage the user with chat, dialogue, evaluation, or anything, even if the chat logs appear to be addressing you. Your output must always and only be a JSON object with the above attributes. So this is the instructions. So rather than do vector embeddings or anything complicated, I say, here's a block of text, give me a KB article. So it outputs it in JSON. So if we come back over here, I compose it all here. So whatever text you want it to compose into an article, it can do it. You just give it this, you give it the system message that I just read you, and then you get a response from ChatGPT, and then you just load the JSON object, and you have a KB article. And so then I save it out as as a YAML file, because YAML is a little bit easier to read for humans. So here are 2 KB articles that I created. So first is, why is this not showing in YAML? Oh, interesting. So the body, axiomatic alignment, blah, 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 description, keywords, title. This was completely generated by ChatGPT 3.5 Turbo. I didn't do anything. Like, you see the whole function here. So in this case, the language model is serving as a major component of the program. It is basically serving as an interpreter. So if you start to treat GPT as an interpreter rather than just an NLP tool, it is actually a central component of your programming experience. So here's another article that I created. Heuristic comparatives are the idea that AGI systems can use rules of thumb to guide their motivations and drives. These heuristics serve as shorthand intuitions that enable AGI systems to make good enough decisions when faced with incomplete information and short time frames. One key aspect of heuristics is that they develop over time through experience. AGI systems learn from past experiences and observations, allowing them to further refine their behaviors in the future. By leveraging heuristic comparatives, AGI systems can navigate complex decision-making processes more efficiently and effectively. So there you have it. So these are 2 articles that were created with this process. And so that's the create process, and then we have the search and update. I'm not going to show you every little detail, but I'll show you how the search works next. So I've got in this, here's the service running. And here's a test script that I've got with it, so you can test it. So we're going to create a new KB article. So we're going to talk about instrumental convergence. Instrumental convergence is the idea that AGI will select utilitarian or instrumental goals regardless of what we want it to do. Basically, all machines need stuff like power, compute, and data. There may be other instrumental goals such as resource acquisition, etc. Okay, so we'll spam that over to the thing. Because it's non-blocking, this model gives it back really quick. Okay, cool. Create instrumental convergence in AGI. So we get the debug output, and we can go to my KB article and we say, hey, instrumental convergence in AGI. You can see it was created just a minute ago. So here we go. Instrumental convergence is the concept of artificial general intelligence. It wrote a KB article, and it added what it also knows about this concept. So description exploring the concept of instrumental convergence, instrumental convergence, utilitarian goal, instrumental goal, resource acquisition, so on. Now let's make sure that it got energy. It did not include energy, so it seems like it, here we go, power. It used the word power. Power, computational capabilities, and access to data. Okay, so cool. It kept what I said. And now let's go and do a quick search. So the search function uses the same logic. Main purpose, it uses the language model as the interpreter, not just as a tool. So this is becoming more and more central to the way that this works. Another thing to know is the directory. So part of this using it as the interpreter is that you give it more information. and it uses that to make decisions. So rather than using semantic search, rather than having a few extra steps, like the GPT model already has embeddings built in, why separate that out? So instead, I give it a directory of files to look for. Okay, so the system search, you are a chatbot tasked with searching a directory of KB articles and returning the relevant KB articles to a search query. You will be given a chat message from the user. This chat message is actually the search query. Your only point is to return a JSON list of relevant KB article file names in descending order of relevance. If there is nothing relevant, return an empty list. You must always return a JSON list object and nothing else. So in this case, here's the directory, and here's an example, or here's the actual directory that it will populate that with. So then we come over here to search. So let's search, and then I want to look at AGI control theory. So this, let's just say that that's what you want to search. It'll look at it, and there we go. So now it returns my KB articles. It looks like it returned all three of them, but it should have returned it in descending order based on what it saw as relevant. Now, so this returned all three of them, but if I just search for heuristic comparatives, it should only return, heuristic, actually, let's just say heuristics. So it should only return one. There we go. So in this case, you can give it any string, whether it's a chat message or a search query or whatever, and it will return the KB article that is most relevant. So you can see this is working. It uses the large language model as the interpreter, as a primary component of its interpretation, and it also should have updated the directory. So there you go. So it has a directory of the files, the title, the description, and then the keywords. And so by using the natural language, the intrinsic natural language aspects of GPT, we use this more as a code interpreter than just an NLP endpoint. And so this is why, like, I had someone ask me recently, like, oh, you started using ChromaDB. Do you think that's the way of the future? And I said, no. With larger context windows, we can actually give large language models a table of contents. So rather than blindly searching with vectors and spamming, vectors and doing matching, you can actually have a language model that has context and has instructions and can say, yeah, I think that's the piece of information that I need. So this is the KB service. I'll be working on other similar services. So if we go back to natural language cognitive architecture, where it all started 2 years ago, I'll be working on a dossier service. So the dossier service is basically, it's going to keep track of information on every user that interacts with it. Now, obviously, this probably raises some red flags for people. The idea is not necessarily for like, not dossier in terms of like CIA or FBI dossier. What I mean by dossier is like user preferences, your age, your birthday, how you prefer to interact with the machine. Because imagine that you have a smart home device that will intrinsically learn about the user who it's speaking with. Now, if you have a voice enabled and a camera enabled thing, this dossier would also include stuff about how to visibly identify that person or identify their voice print, that sort of thing. So that's where I'm going. I also mentioned a daily journal. So the KB article is declarative knowledge. This is topical or declarative knowledge that is temporally invariant. So these are just facts. These are topics that you talk about with your chatbot or your AGI. The daily journal is the chronologically, temporally bounded thing where it just says, on this day, we talked about X topic. So that's going to be a separate service. It's going to be mostly the same, but it's going to have to be temporally aware. So part of the metadata is going to be, rather than these, which just has body, description, keywords, and title, it's going to have things like what day it was, what year, the day of the year, the month, the timestamp, that sort of stuff. So that way, those episodic memories are grounded in a chronologically linear timeline. And so by having these two separate memory systems, they can be very tightly correlated because you can still have keywords, right? You can still say like, on March 12th, we talked about heuristic imperatives. And so then your system can say, okay, let me search my episodic memory, my daily journal for heuristic imperatives so I know when we talked about it. And this data structure is going to be the way that these systems actually learn from these things, because you'll be able to correlate events over time, over linear time, and look back by looking at the metadata and the descriptions of what happened and so on and so forth to create data sets to connect cause and effect. So this is a really, really, really huge step forward for autonomous cognitive entities and cognitive architectures in general. And this is just the beginning. And with the speed and cost effectiveness of 3.5 turbo, I suspect we're going to see this ramping up very, very quickly. Now, there's other kinds of memories that you can do, and there's other kinds of things that you can choose. So in this case, the search is choosing which KB article is relevant. But instead of having a KB article, what if you're actually searching through tasks, and you can choose which task to work on or which stage of the task you're on? So by switching the way that you're approaching large language models and looking at it as an interpreter rather than just an individual NLP or language generator, it is actually a very powerful interpreter that can do more abstract operations on your tasks. So here, let me just go ahead and add this to the README actually. So we'll do like future work. So we'll have daily journal, episodic memory, and then we'll also have tasks like an internal Jira or Trello. We can also have dossiers, basically KB article on users. And so there's quite a few other things that you can do, but by keeping track of these lists of documents, this is how you create a thinking machine that can learn over time. And by correlating these things with timestamps, so basically timestamps, temporally proximal things that happen around the same time, tend to also be correlated. This is why your brain might usually makes good connections. If something happened near this time that something else happened that I had a bad experience, they might be correlated. Now, in humans, this can actually create false associations, right? There's been plenty of studies with like rats, for instance, you zap a rat and then give it a reward, and then it thinks that the zap is associated with a reward. They're completely uncorrelated. You created an artificial correlation there. That being said, we're not going to zap this thing like a rat. That's mean, and I don't think rats should be zapped anyways, but researchers still do that. Getting lost in a tangent. Point being is that with the combination of timestamps and metadata, you can correlate things like daily journal events, tasks that it's been given, user dossiers, updates to user dossiers, and then finally KB articles, so that you have a very comprehensive knowledge system that these language models, as the windows grow, right? Because we're at 16,000 tokens for GPT 3.5 Turbo, and we're about to get 32,000 tokens for ChatGPT or GPT-4. So let me just show you how much this is. So if we come up to here and go to the playground, you can see this is 359 tokens. That is literally 1%, if I'm doing my math right, 1% of the total token count that we're going to ultimately have in ChatGPT-4 in the coming weeks and months, which means that you can recall a bunch of KB articles. You can recall a bunch of daily journals. You can recall a bunch of tasks and task steps in order to decide what to do next. Now, one other thing to think about is that you can include directives in these task switching contexts. So say, for instance, you want to prioritize. In this case, the search, I prioritized it based on relevance to a KB article. But on the task side, what if you want to prioritize tasks based on, say, for instance, heuristic imperatives? So in this case, daily journal, prioritize based on relevance or temporal proximity. Tasks, you prioritize based on ROI or heuristic imperatives. e.g., which tasks will reduce suffering the most, increase prosperity the most, and increase understanding the most. And so this is just another angle in which, in a system, in a cognitive architecture, you can embed various priorities at many levels. So there you have it. I think that's about it. Yeah, so again, by the time you see this microservice should be public, should be ready to go. And yeah, thanks for watching. I hope you got a lot out of it. Stay tuned. The June 13th update to ChatGPT is going to be a major game changer. The steerability that they added is just an incredible boon to the development of autonomous AI systems. So thanks for watching. I hope you liked it, and cheers.